Hi everyone, welcome to this session, and we are very excited to have Dr. Nitin Saini with us today. Dr. Saini is a professional and social entrepreneur with a doctorate in business administration and MBA and a degree in civil engineering. Currently leads strategy initiatives for TCS government business. Dr. Saini is also the co-founder of Samvalam Aman Somvivam Foundation, which focuses on education, health, and sustainability. He is a gold certified mentor and agile coach and has on education, health, and received several awards, including Yogdhara Global Achiever Award. So today we will be discussing about AI and digital transformation, and also we'll learn about Industrial 4.0. Dr. Sani, hand over to you.
Thank you. Thank you. I hope you're able to see my screen.
Yes, it's visible.
Okay. Good evening, everyone. Today we are going to talk about Industry 4.0. It's actually a very vast subject, Industry 4.0, but I'll try to cover it in 1 hour. In case you have questions which are absolutely necessary to be asked, please stop me and ask the question. Or if the questions can wait, I would encourage you to wait until the presentation is over. So today we are going to cover these things. I'll briefly tell you the history of Industry 4.0. Then we'll go into the technologies of Industry 4.0, and then we'll talk about why Industry 4.0 is needed, and then followed by any questions and answers you would have. So Industry 4.0, it's actually the fourth revolution, fourth industrial revolution that we talk about, and that's why it's called Industry 4.0. There have been first industrial revolution, second, third, and currently it's fourth, and soon there will be fifth industrial revolution as well. Let's understand what these revolutions are. Now, can any one of you unmute and tell me what is this? What do you see on the screen? Anyone? Okay, so this is atta chakki. What this guy is doing is putting the wheat and running the chakki with hand so that it gets the wheat flour out of it. This is the way how the atta used, I mean the wheat used to be ground into the flour. Now this is the water wheel. After the invention of the wheel and the uses of water, the wheat was then grinded using these water wheels. So the two stone circles that you see that used to grind the wheat. Then came the electrical atta chakkis that you would see in your neighborhood. You put the wheat and then you get the flour out of it. And then this is a flour mill wherein tons of wheat is ground and made into flours, and it's packed into the sacks. Now, in those four images, what you have seen is the four industrial evolution. In the early stages, everyone used to use their manual um, work to get the things done. So if you were to grind the wheat, you would use the manual atta chakki. And then the first evolution came in, wherein the mechanical parts came in, especially with the water and the steam. That's when the steam engines also started. And then people started using the water wheel to grind the wheat. Then came the second industrial revolution, which introduced the mass production facilities with the help of the electrical energy. That's where you see the atta chakki around you. It's run by electricity and it can, grind wheat in a large amounts. Then came the third industrial revolution, wherein the programmable logic controls came in. And that's where you see the floor mills there. Yeah, it's all connected with IT, and it's also run by electronics, and you get tons of wheat flour coming out of it. Now we are into the fourth industrial revolution, wherein the cyber physical systems are working together. So it's actually merging the real and the virtual worlds. So that's how the things have evolved. So the steam power was uh, invented or discovered somewhere around 1784, and then 100 years later, you got the second industrial revolution, another 100 years, then you got the in the third industrial revolution, and today we are into the fourth, on the verge of starting the fifth industrial revolution. So that's again the same thing. First industrial revolution, purely human and animal power, wherein you would have seen the farmers going to the farm, and then cows and the bulls, they would be, doing the normal farming stuff. Then when the second industrial revolution came in, the things started changing, and then the things were done differently with the help of mechanical power, wherein the hull came in and other things came in. Then the third industrial revolution, the tractors and all those things came in, which were quite smart. And in the fourth industrial revolution, you have high-tech machines. Those are called mm, they have multiple things. Those are called combinators. You can do the plowing, you can do the harvesting, you can do a lot of things like this. Now, if you look at the key characteristics of Industry 4.0, these are the four key characteristics. One is the acceleration through the exponential technologies. So you will see in the upcoming slides what technologies we are talking about. These exponential technologies actually accelerate any of the work, be it the production of the stuff, or making the new designs, or solving the complex problems. You're able to do because of the exponential power of these technologies. Then comes the vertical networking. Now, with the Industry 4.0, the smart factories have come in, the smart products have been come in, and likewise, you will see how the vertical networking of the system within the factory actually helps thing they do very efficiently and very effectively, making needs oriented, customer specific operations. The third thing is the horizontal integration, wherein, when you are talking about the businesses, now it's all the global ecosystem. So most of the companies are global, and how they are creating the value networks across the globe, how they are able to integrate the things together to address the customer needs. And last is the through engineering. So you have to put the engineering at all the stages of your value chain. Only then you're able to leverage the Industry 4.0. We'll understand these things in the coming slides. Let's first see what are the design principles of Industry 4.0. These are the six design principles. One is interoperability, which means you should be able to work with the other partners within the organization and outside the organization. Second is the virtualization. Leverage the power of virtualizing the things, be it the design, be it your compute power, be it storage, be it whatever be the thing. Third is decentralization. You don't want everything to be controlled at one place. You need to have the things federated. The control should be given to the individual entities. So, for example, if you have the production facility in three different locations, let's say India, UK, and US, then each of those entities should be able to operate individually rather than somebody sitting here in India controlling the UK facility and the US facility. Then you need to have the real-time capability. You would be able to improve your processes. You will be able to leverage Industry 4.0 only when you have created the real-time capability into it. And we'll see how technologies will help create the real-time or near real-time capabilities. Fifth is the service orientation. You have to see that each of the parts or the departments in your organization is service oriented. Each is delivering a service to the other department. So when you are service oriented, you give the service to the customer. Your departments are giving the service to you. And then likewise, when you are service oriented, you tend to improve the services well, bringing out the efficiencies. And lastly, your system, your organization has to be modular enough so that you are able to scale it well, you are able to integrate it well. Now, these are the building blocks of Industry 4.0, and these are also the technologies involved in Industry 4.0. I'll start from the top. One is additive manufacturing, then augmented reality, autonomous robots, big data, cloud computing, cybersecurity, system integration, IoT, and simulation. We'll go deep into each of these technologies to understand how it is enabling Industry 4.0. So as I said, these are the 9 technologies that we are going to cover in the upcoming slides. We'll start with additive manufacturing. Now, additive manufacturing is also known as 3D printing. Everyone must have heard about 3D printing. Some of you might have actually had the opportunity to try out 3D printing, be it printing of the keychains, or printing of some decorative items, or printing of some useful material for your project, and likewise, that is how the 3D printing is leveraged. Now, interestingly, additive manufacturing or 3D printing, this is very different from the traditional manufacturing. Anyway, before we go into the difference, let me just briefly touch upon the history of additive manufacturing. It's nothing new. It has been in the existence for quite some time. In 1995, 1985, the additive manufacturing was figured out. The first use came in through the stereolithography process, and it was launched in 1987, this AM system. Then the first generation acrylate resins were used for 3D printing, and likewise, they brought in newer materials to create the 3D prints. So earlier, these 3D prints were used uh, uh, with a very specific material, and that was used for tooth replacement and all other things. Slowly, they figured out they can do the additive manufacturing with other materials as well. Now it is being used with plastics, it's being used with metals, and it's being used with concrete, it's being used for many other things. And the cost of this additive manufacturing has actually decreased quite a lot with the new materials coming in and the size of the 3D printers becoming compact. It's now very much affordable. A typical process of additive manufacturing starts with a CAD design. You make a 3D model of what you want to print. Once it is rendered well, you create this into a .stl file. Once the .stl file is created, then you create the layers out of it, these slice layers, and then you feed it into the 3D printer. The 3D printer reads these slice, and then based upon the material, it starts printing it. Once the product is finished, then I mean it's completed, then you do the finishing. There might be some material hanging around, or it might need some polish or something, and then you get the final product. That's how the additive manufacturing actually works. Yeah, now let's come to the difference between traditional manufacturing and additive manufacturing. The traditional manufacturing is deductive manufacturing, and I'll explain you how. If I were to give you a block of stone, or let's say a block of marble, and say, can you create a murti out of it? Let's say Ganesh ji ki murti, if you have to create, how would you do? You will start chipping off the material out of it. So if I've given you 1 meter square stone, and you start chipping off, and eventually you create the Ganesha, you would have wasted a lot of stone. I mean, because it's being chipped, a lot of chips would be all around, etc. So it is the deductive. Whereas in additive manufacturing, once you have fed in the design, it starts printing it. So it keeps on adding the layers on top of it. So it reduces the wastage. And by doing the additive manufacturing, you can actually do the complex designs because you have done the simulation into the system using the 3D software. And then you can print this very easily, which may not be possible in the traditional manufacturing. Because of this, you get the faster speed to market. You can bring the products quickly, fast. Now, the advantage of the traditional manufacturing is once you have finalized the design, you can do the mass production very quickly. Whereas in additive manufacturing, it is a slow process. You cannot print thousands of things in lesser time. It takes its own time because it's adding layers one by one. You have a lot of choice of material in the traditional manufacturing, whereas in additive manufacturing, it's a limited set of things that you can use. Typically, plastic is used in the college labs and the school labs, but there are other technologies, other ways how the other things can be used. Some of the technologies are listed on the left-hand side, started with the stereo lithography, wherein the design was created upside down when the 3D manufacturing started. So if you were to create the idol of Ganesha, it would start printing the legs uh, upside down, and it would create the layers, and eventually the head would be printed. So you will get the Ganesha idol totally reversed. Then the new technologies came in, for example, the multi-jet modeling, then electron beam melting, then sintering technology came in, and heat sintering, laser sintering, all those things came in. And today we have the laser metal disposition as well, wherein what you do, you put the metal powder onto a plate, and the using the AI and all other technologies, the metal is fused and one layer is created. Then you put another layer of the powdered metal, and then it fuses and creates. So you can actually create the metal idols or metal parts out of it by 3D printing. That's how it has evolved. But again, additive manufacturing has the limitation that um, it cannot have a lot of materials, very select materials. Those have been successful in 3D printing. If you look at the applications of additive manufacturing, one is the aerospace and defense. You would be surprised to know that one airplane has almost 1 billion parts, and the procurement cycle is really, really long. If you were to replace one of the components in a airplane, it has a long cycle. But if you have the additive manufacturing, you can print those materials in the workshop, and then you can replace it faster. Same thing goes in the space. Once the space station has developed some issues, you have to launch another rocket to send that part to the space station. Whereas if you have the additive manufacturing, you can print the stuff then and there, and you can fix the things. In automotive, a lot of parts are now being made out of aluminum. A lot of parts are being made out of plastic. To reduce the procurement cycle, they have started using the this 3D printing for some of the auto parts that can be done, that can be created in the workshops and can be replaced. Same goes for the healthcare. The prosthetics that you are using, earlier it used to be plaster that you used to put. Now the 3D prosthetics can be put in, 3D plaster can be put in, which is lightweight and gives a lot of air rather than very compact. And likewise, even they have printed the organs. One of the lung was printed recently, not recently, about 2 years back. That was successfully done, and it was implanted into one of the transplant surgeries. And then in the retail space, especially in the consumer product, you can actually make a lot of designs very quickly using the 3D printing, and then you can put it out into the market, especially in the jewelry space or the watches space, where the parts are really tiny and those have to be really precise. You can actually customize this product and bring it out. The second technology is augmented reality. You must have heard about all these terms. Augmented reality is nothing but it's overlaying the digital content on the real environment, and it's quite different from the virtual reality. Sometimes, people confuse between virtual reality and augmented reality, but it's slightly different. This is how the virtual reality and augmented reality is different. When you recreate the real world environment into a virtual environment, that is a virtual reality. Whereas when you superimpose some of the virtual environment into the real world environment, it becomes the augmented reality. So you can see two different images there. The image on the left, that is seen using the ocular lenses, and you will see the virtual world. You will not see the real world, but only the virtual world. Many of the games that we play, it's nothing but the virtual world. It may be in 2D. Using the VR glasses, you can actually get an immersive experience. You can be into the environment, but that environment is not a real environment, but a virtual environment. Whereas the image on the right, you can see a device is showing the actual picture of the real environment and overlaying it with some digital information. So that is the augmented reality. This is very much used in retail. It is also being used in the fashion industry to try out new outfits. You can actually switch on your camera and you can actually see how this things works. Also, um, In this Google Meet, in Zoom, when you put the filters, when you change the background at the back, it is nothing but the augmented reality. And the real environment, I mean, the real person is still there in the image, but the background is replaced. Now, using this augmented reality, there are many opportunities. You can actually connect. You can collaborate with people without co-locating. You can hold the meetings with the augmented reality. You can learn a lot of things about the architecture, maintenance, design using the augmented reality. For example, if you were to study the historical monuments to understand what type of architecture was used here, what kind of material was used here, AR can actually give you all that information. Then you can use this for learning purposes. You can have the immersive trainings. It's being used in the healthcare to perform virtual surgeries and to see how the things would happen if you were to do the things in the real life. You can actually use it for journey across the time. You can have the augmented shopping. You can have the augmented travel, and likewise, and games and videos. You can have live events as well. One of the live events using the augmented reality was conducted um, about 4 or 5 years back, wherein one of the bands actually used this augmented reality, and you were able to participate into the environment with your friends, even though they were not co-located. And then with this augmented reality, you can actually evaluate the solutions, you can figure out the best practices, how to do this, and likewise. So if you see, there are numerous use cases in various sectors. It can be used for augmented shopping. It can be used for location-based visualization, augmented catalogs. You can have field services. You can enhance the physical products across retail, healthcare, construction, pharma, manufacturing, etc. So the use cases are enormous. They are slowly evolving as new use cases are being figured out. It's being adopted across the sectors. The third technology is autonomous robots. You all know about the robots, and Elon Musk is also building one robot. And these robots are not only used for general purpose, but they are used for very specific purpose, especially in the manufacturing. And every day, new advancements are coming in the robotic technologies. It started with the robotic arm. Now you have full-fledged robots which can stand just like human beings. They can work and engage with conversations with the human beings. Now with the robots, there is another term that has come out, which is called cobots. Now, if you look at robot, what is a robot? Anything that a human does, if the machine is able to do it, it's called a robot. And when you put autonomous in front of it, autonomous means it can do independently of itself without needing anyone to interject and interact or give any human influence. It's an autonomous robot. Whereas a cobot is a robot that has been designed and it can work along with the humans. A simple example is if you have looked at the assembly line of a car, various parts are welded together, various parts are painted, and a lot of connections are done. Many of these things are done by the robots, especially when they fix the doors, then they put the body onto the chassis, and likewise, everything is done by the robot. However, the human also works there by putting up the seat, and they are doing other things, fixing up the interiors, dashboard, all those things. So when robots and humans collaborate together towards achieving something that is called a cobot. And why do you need autonomous robots? Because they have high endurance, they have high speed, they have high precision. So, and you can tell them to do this kind of a thing, and they will always do this thing without getting tired. Whereas a human being would need a break in between, asking, maybe I can go to a washroom, can I have a cup of tea, and all those things. Machines, robots, they don't need a break. They can work continuously. Now, where to use robotics, where to use advanced robotics, and where robotics cannot be used. It's if you look at the environment and the task complexity, if the environment is fixed, no logic is required, traditional robotics works. But if some logic has to be applied and the environment is flexible, then you would need the advanced robotics. Whereas if the environment is unstructured and you need to develop the logic, that will always be done by humans. Slowly, this green area is increasing as more and more advancement is happening in the technology. But uh, there is a lot of time before this will completely overlap what humans can do. Human is the most sophisticated robot you can assume. That sophistication we haven't achieved yet, and this is when we are using only 10% 10% of our brain. If we were to use 100% of our brain, I'm sure any of these machines cannot match the intelligence and the sophistication a human being has. As I said, autonomous robots, they're smart, they're easy to use, they're ergonomic, it can improve the productivity, and with high precision, with good accuracy, and you can collaborate with them. One example in improved productivity that I always tell, Zara is a brand you must have heard. Its parent company is Inditex. Now, what they have done using the robots and the use of technology, they have reduced the time to bring any product um, into the shelf in just 10 days, right from design to producing any of the new design into the Zara store. It takes only 10 days, whereas other players, they usually take 3 to 4 months, right from designing to selection of the material to stitching and packaging and logistics, all those things. Whereas Zara, I mean Inditex, they have fully automated end to end. It's only 10 days. You will find it in the shelf. There are numerous examples where robots are now bringing the transformation. The next technology, the fourth technology, is big data and analytics. Those must be some of the familiar terms. Big data is nothing but a collection of huge amount of data. If it is huge volume, a large variety of data, and from coming from multiple sources, it becomes the big data. Now, with the invent of IoT, Internet of Things, we'll talk about the IoT in the upcoming slides. The data that is incoming to us is increased manifold. That is why it is called big data. A typical process to handle the big data is you will collect the data first, you will cleanse the data, then you will process the data, and then you will analyze the data. This is the process which is very much similar to BI as well. And many people ask, what is the difference between BI and advanced analytics? See, BI is post facto. The thing has happened, and then you do the postmortem of what has happened, when did it happen, who did it, how many times it has happened, and you do it through reporting, some dashboard, some scorecards, you make the cubes, you do the slice and dice, and you do all those kind of things. Whereas in advanced analytics, it is not post facto, it is pre facto and trying to predict something that can happen in future. So if something has happened, they will see why did it happen? Can it happen again? How can we avoid such a thing? And with all of the data, what else we can figure out? We can also figure out the things that were never asked. And you use it through data mining, predictive modeling, multivariate analysis, and other kind of analytics. Now, big data and analytics, the benefits of using big data and analytics is you can retain your customer, you can acquire more customers, you can have the targeted ads. It helps in the product development, price optimization, supply chain and channel analytics, decision making, risk management, and likewise. Let me share one example. Uh, Once I was planning to buy one of the pair of shoes that I always wanted to buy, and I wanted with a very peculiar specification. I wanted without the laces, and it has to be brown in color, and it has to have the pointed head, and it should be very soft, and all those things. And I was discussing this with my friend over the phone. Next morning, when I opened up Google, I saw a lot of ads coming of the shoes. And interestingly, all of the shoes that had the same design what I wanted, brown in color, pointed, without delaces, etc., and good brands and all those things. The things became even more interesting when I was into the mall and I was standing in front of a store and I was looking at the uh, similar shoe that I wanted to buy and the ads that I have seen, and I'm just looking at the price. And suddenly I get a SMS and it says, you get 20% off if you buy in next 1 hour. Right? It was all because of big data and analytics. As you would know, anytime we are talking, the devices are continuously hearing and the data is being processed, and that's why the personalized recommendations come to you. That's why I saw those ads on Google showing me the shoes and all those things, and you can try it in your real life as well. Try to talk about a product to anyone over the phone, and next day you would find the similar ads coming onto your browser or the social media feed. And now the big data analytics is being utilized. I mean, not only big data analytics, other technologies as well are being used by the retailers in such a sense. They know that I am standing in front of the store and they don't want to lose the customer. They immediately gave that personalized offer to me that if I buy next 1 hour, I get a 20% discount. It was not a regular thing. None of my other friends got such a SMS. It was only me. And this is part of the retail strategies, how to acquire the customer and how to retain the customer. So that's how the big data analytics is actually helping in the real world. The fifth is cloud computing. You all should be knowing about cloud computing. We'll briefly talk about this. You know, when you are designing the systems with IT, you need to have some storage, you need to have some compute. But when the things start growing, you need to increase the compute and you need to increase the storage. You cannot go and buy the servers every now and then. You cannot go and buy the hard disk every now and then. You need to have the flexibility, and you want your system to be available. You don't want any of the customer to go dissatisfied. Hey, your system is not working, it's hanging and all those things. So cloud gives you all that kind of flexibility. So networks, the servers, storage, databases, networking, software, analytics, intelligence, everything is available now on the cloud. So some of the names you would know is AWS, Azure, Google Cloud, and other clouds as well. The entire um, uh, the size of this market is really huge, and you can see Amazon is leading with 180 billion dollar share coming from the cloud market. Now in the cloud, you can actually get the compute, storage, and other services in various models. First is the infrastructure as a service, which is called IaaS. Then you have the platform as a service, which is also called PaaS, and then software as a service, SaaS. So IaaS, PaaS, and SaaS, these are the three ways how you can procure the cloud services. In each of the model, there are certain things that you will manage, and there are certain things that the cloud provider is going to manage. When you want the full control with yourself, at least on the application side, you will go for infrastructure as a service. If you don't want to really put your head into managing the application, the hardware, etc., then you go for the software as a service. Google Mail is one good example. Google Meet is another example, which is a software as a service. I don't care how it is built, who has created this, who is storing the data, where it is being stored, what middleware is being used, how many servers are involved, what storage is provided, what networking components are involved into this. What I care is I am getting the software, my purpose is getting met. It's a very simplistic example of software as a service. Then comes the adoption level. Now, historically, the government sector or the public sector has been the laggard in adopting any of the newer technologies. Whereas the digital natives or the startups, the media and the gaming, those have been leading the industry by adopting the newer technologies. And the same thing is there in the cloud computing as well, followed by retail, large customers, manufacturing, and public sector. But now the things are changing in India with the digital India. coming in, all of the newer initiatives resting on cloud computing. It is no longer a laggard. It's actually leading the way how the cloud computing can be utilized in some of the regulated industries. And we saw the benefits of the cloud. It's very much manageable, 24 by 7 availability. You get automatic software updates, you get security, you reduce the carbon footprint, you have the control on the data, on the documents. It's easy to manage, it's flexible, it's accessible anywhere. You can have better collaboration. Just like you all are interacting with me, it's all through the cloud. Then the next technology is cybersecurity. This is also a familiar term. Everyone is talking about cybersecurity. With all of this data, big data coming in, and data has all the information that you can leverage for multiple purposes. So you have to save the data. You also need to save your systems so that nobody is misusing that system, and they are not misusing the data for any of the malicious purposes. So you need to put some security controls around your systems, your applications, your data, so that everything is safeguarded. Digital arrest is one of the example. That is one of the cyber uh, threats that we have seen. There are many more. A lot of cyber attacks happen every now and then. Recently, there was a cyber attack in Japan wherein the airlines was brought down, and the systems of the airlines were brought down. They were able to recover this quickly. But those kind of things have happened. There was an attack from China into India wherein the power of Mumbai was shut down for 2 hours. And that's where the BSNL actually came in, and public-private partnership happened, and Tatas are now building that BSNL network along with the government, the 4G network, and all other things. So if you look at the type of cyber attacks that can happen, it starts with phishing and the social engineering attacks, wherein you get the malicious link, you click on that link and something will happen. It may be just, extracting the money out of your account. It can uh, release a virus. It can do any other thing. Then there are internet-facing services. DDoS attacks are very, very common. They distribute a denial of services. There are bots that can actually act as the users, and it can overload the system, bring that down. Then password-related account compromises. Every now and then, Google keeps on prompting you have a weak password, or your password was figured out somewhere on the dark web. Now the antivirus companies are also giving these services. They keep on checking the dark net, whether your information is getting leaked there or not, your password has been reused, or it has been compromised, and all the things. Misuse of the information. We keep putting a lot of pictures onto the social media. Some nasty fellow is going to take that picture, morph it, use the deep fake, and do whatever you can think of. Or if you have put out some information, and I'll share one instance what has happened. One of my friends actually put out the flight tickets, the picture of the flight tickets onto the social media as the status on WhatsApp. And another friend actually put out one picture of a product that they had bought from Amazon. And when they clicked the picture, the label, the shipping label was also clicked because it was kept onto the Amazon box, and the shipping label was there. So all of that information, the entire address, the name of the person, everything was revealed. I informed, hey, your information could be misused and uh, can be used for wrong purposes. So they removed the images. Another instance I'll tell you in Tamil Nadu, one of the cases that has recently happened. When you have the property documents, you have to put the fingerprints onto it. All five, including the thumb, you have to put the fingerprints. When you're going and buying a property, you can actually ask the owner to share the registry papers, and registry papers have those fingerprints. So some nasty fellow, what he did, he extracted the fingerprints from the paper, created a silicon a fingerprint out of it. And the Aadhaar number is also mentioned in the registry papers nowadays as the identity. He used that Aadhaar number, fingerprints, and he withdrew all of the money from the seller's account. So such nasty things are happening. So as new things are getting discovered, new ways to secure the information is coming up. Now, if you go to Tamil Nadu and try to download such a registry paper, it will automatically mask that fingerprint as well as the Aadhaar number whenever it is getting downloaded, so that nobody is able to misuse that personal information. Then other attacks are the supply chain attacks. It could be network related, man in the middle attack, ransomware, denial of services. All of those things you must have heard. All of these are the types of cyber attack that can happen, and it can bring the systems down. Now, while these are happening, what is that you can do? So you can put the controls everywhere, right from the infrastructure to the application layer. There are multiple security layers. You can have the network and perimeter security, you can have the endpoint security, you can have the application security, data security, identity access management, zero trust architecture, which is the latest thing that has come in. Every cloud provider is now relying on to the zero trust architecture. It basically says you have to authenticate every time. Don't assume that I know you. Every time you have to prove your identity whenever you come and access any of the systems in my applications. Then next is horizontal and vertical integration. Now this is the backbone, the integration horizontally as well as the vertical integration. Now in horizontal integration, what happens is the processes are tightly integrated right at the field level. I mean, from the topmost level to the field level, everything will be integrated. In vertical integration, what happens is, no, I'm sorry, in horizontal integration, the information is integrated across multiple regions. And in vertical integration, within the entity, everything is tied up. And we'll see this with an example. So if you were to network between the manufacturing sites, that would be a horizontal integration. You might have a manufacturing facility here in Gurgaon, and you can have the manufacturing facility in Hyderabad. If both of these sites are talking, that is horizontal integration. Customer can also be involved. For example, if I'm buying a car and it's not available in Gurgaon and it's available in Hyderabad, then I ask the Gurgaon plant, please have me give me this car. It can actually send the message to Hyderabad and bring the car to Gurgaon so that I get it. So customer can also be involved in this. And in whole of this thing, the information is exchange in the value chain so that I get what I am looking for. I mean, I as a customer, I get everything. Now, vertical integration is the integration between that entity. So within Gurgaon, there would be multiple departments that are responsible for that manufacturing. If all of them are talking together by the way of technology, then it is the vertical integration. A quick example, if let's assume there is a car manufacturing facility, one in North America and one in India, and the cars have to be delivered to a customer which is based out of Europe. He puts out the order, and because there are multiple factories, both of them can deliver the cars to Europe. Whereas, but in the real case, the order is taken by the American facility, and it start producing the car, and suddenly they figure out their assembly line is broken. And since they have to meet the commitments of the made to the customer, they have to deliver the cars anyhow. So this facility in US automatically contacts the facility in India and says, hey, my assembly line is not working, can you take up that load? And automatically they talk to each other and ensures the manufacturing the car happens in India, and the cars are delivered to European client. So in this, when both of the facilities have talked to each other, that is the horizontal integration. Whereas within one entity, if all of the departments are talking, right from the procurement to logistics to finance to shop floor, everyone is talking to each other, that is the vertical integration. Then second last technology is Internet of Things. You might have heard IoT is very common. IoT is used so that data is given to the systems as quickly as possible. So real-time capabilities only come when the IoT system is quite efficient, right from supply chains to actually manufacturing of the stuff. So IoT basically gives the ability for the physical objects to generate the meaningful data and send it to the system so that some actions can be taken. So business is performing some of the activities like manufacturing the goods, selling the goods, managing people, finance risk, etc. In this whole process, the sensors are producing the data continuously. It may be the data related to the temperature, it could be related to vibration, lighting, movement, location, humidity, whatever be the data. This data is getting collected and the big data is created. You can do the data analysis either in the cloud or you can do the analysis at the edge. When you do the analysis near to the sensors, it's called edge analysis, whereas if you take it on the cloud, it's the normal typical data analysis. Each of these analysis will lead to some insights, and these insights will lead to some decisions or actions. Once these decisions and actions are put into practice, again, the activities may change, which may, accordingly change. So it's a continuous cycle. The data what you acquire is for doing something better. Once you understand the things doing better, there are new data or a different set of data that comes into picture, and the cycle continues. That is how the things continuously improve. So as I said, edge computing, when you are doing the analysis near to the centers, near to the sensors, it is called the edge computing. You can see the wearables that you wear on your hand, the smartwatch or Fitbit and all those things. They have now the edge computing. And it is very much important because you cannot wait to figure out, hey, what's my heart rate? Uh, Waiting that this data will be sent to the cloud, and cloud will then return back, hey, your BP is 180 beats per minute or something likewise, right? So um, because the lives are involved, the risks are huge. So the computing is now moving towards the edge, to the edge devices. You can see this in autonomous vehicles. Suddenly, if a pedestrian comes in, an autonomous car is going, it cannot wait for the signal to go to the cloud and then come back and say, you need to brake. By the time that data exchange happens, probably it would have hit the pedestrian. That is why the edge computing is needed in autonomous vehicles, same in the healthcare devices, same in the security solutions, same in the retail advertising. We cannot afford to lose the customer just waiting for the signal to come back from the cloud to tell what to do next. Instead, the analysis is done there so that you don't lose the customer. Same with the speakers, same with the video conferencing. As you would see, slow links that can actually cause problems like you cannot hear, especially in the corona period. We all observed this. Hey, can you repeat this? I can't hear you. The network is slow. I can't see you. Your voice is muzzling and all those things. Then comes the simulation or the digital twins. This is something new. You might or might not know about this thing, but a digital twin is the replica of the real world created digitally. And the need for doing this is to play around with the things. And I'll give you an example. Each of the naval ships that are created, they are of the tune of 600 crores or more. You cannot make a naval ship, put out into the sea just to figure out that it cannot bear that much load. And because it's a huge ship, you have to put the nuclear reactor. You cannot just put the nuclear reactor just to figure out that all of the metal gets melted because of the heat generated from the a reactor. So you have to do all this modeling in the simulation to figure out, hey, what will be the temperature? Will my metal gets melted? Or I have planned this ship to carry 37 aircrafts. What if during the wartime I have to land two more aircraft? Will it sink? Will it not sink? So you do all of those things in the simulation before putting out into the trial, because the cost of failure is really, really huge. So looking at the physical world, you create the digital twin out of it. And then you will put some sensors and actuators onto the real world thing. You will collect the data, you will integrate it, and you will see how the things are behaving. And you see the similar behavior in your digital twin. You make the course corrections, make it as similar as what is there in the real world, and then try out new things to figure out how I need to modify the design, how I need to change the processes, and likewise. So, as I said, you create the digital twin, you start communicating with the digital twin, you aggregate the data, you analyze the data, you figure out the insights, and then you act accordingly. For example, if you put out the nuclear reactor of 100 megawatt and it's producing enormous amount of heat, then you can say, okay, I need to put another shield out of it, and you put the shield so that heat doesn't come out, and then you see how it reacts, and you simulate back into the environment in the digital twin, and you see whether I am exceeding the weight or not, because I'll be using so much tons of material to insulate it. And then if I put another aircraft, it weighs so much, will it sink, will it not sink? And likewise, you do such kind of things. I gave one example, but it's applicable in every sphere, be it the manufacturing line, assembling line. You can create the digital twins to see, what if I start producing more products in one assembly line? Will the wear and tear increase? How soon I have to replace the parts, and a lot of things. The value that you get from simulation or the digital twins is you can improve the quality, because you are able to see when the things are going to fail in the digital twin, and then you improve the quality. You either put it out into the packaging saying this can be used for 10 hours, or you improve the quality to ensure that it works for 50 hours. You can reduce the warranty cost and the services. You can reduce the operations cost. You can reduce the record retention and the serialization, because you will have the digital record of all the parts. And because you are simulating in the digital twin and seeing all of these things, you don't have to really order the parts, try it out and figure out what parts I have used, what parts are not available, and all those things. You can reduce the introduction time and the lead time of any product, because you are able to simulate. Once you are fairly sure, yes, this is going to work, then you start the production and bring out the products quickly, rather than actually bringing out the product to figure out, hey, doesn't work, let me change the design. Hey, this is still not working, let me change the design, and likewise. And in this whole process, you get a lot of revenue growing opportunities. You can bring new products, you can do a lot of things around that. Now, with all these 9 technologies that I spoke about, Industry 4.0, the question still remains, why do you need Industry 4.0? I mean, all of these technologies are there. Why do you need Industry 4.0? So these digital technologies, they are leading to increased automation. It is leading to I mean, you need increased automation, you need predictive maintenance, you need the optimization of the processes, and you want to achieve better efficiencies, better responsiveness, which means you, you need intelligent products, you need the intelligent processes, you need intelligent factories, assets, and you want the people to be empowered. This is possible only when you use Industry 4.0. Some of the benefits that we can see of using Industry 4.0 is you can have enhanced productivity, because now you're using automation, the processes are optimized, you can have better agility, you can bring more and more innovation into it, you can have new revenue models, because you're getting the real-time data, so you can see how the things are happening, and you can make the quicker decisions. You can have the personalization. As you are acquiring new customers, they get the personalized recommendations, they know what uh, they need. For example, if you look at Amazon, it keeps on giving you the recommendation, hey, when you buy this, other customers bought this thing, or you can buy this and this at so much price. All those things are needed. And with the real-time monitoring and IoT, cobots, you can have better quality products, you can have better working conditions, sustainable conditions, and likewise. Some of the use cases of Industry 4.0. So one of the Fortune 500 company, what they did, they brought in various product variations, and operators' effort was reduced, the quality was improved, and eventually they were able to get their product right on the first effort by more than 10 percentage points. So that is the kind of improvement we are talking about. Then you can streamline the processes. So one of the company which created 10,000 SKUs across the 6 assembly line, using the robots and the cobots, they were able to increase their labeling speed from 125 parts per hour to 250 parts per hour. And because of the robots, they needed less space, so they were able to reduce their floor space by 200 square feet. One of the manufacturers of the truck engines, they actually use the 3D printing. They reduce the tooling time from 20 weeks to just 2 weeks, and they decrease their tooling cost from $10,000 to just $770. So you can reduce your development cost, you can reduce your lead time, and you can have the accelerated market entry. One of the industrial goods company, what they did is they accelerated their penetration of the products in developing markets. They were able to reduce the quality claims by 90%. They increased their production throughput by more than 25% by the way of implementation of Industry 4.0. Then you can create new services. So one of the tire manufacturers, what they did is they initiated this initiative called Tires by Mile. And while they are giving out the tires, they are able to generate new revenue for the company. And this is specifically when the tires are used in trucks and all other things. As the tires go by the mile, they are able to generate new revenue. Then you can improve the efficiency. One of the automotive equipment, they actually leverage their digital strategy, and they were, they were able to put out the initiatives, test it out, and quickly showcase what value the digital is actually bringing in. So all those things are possible. You can optimize the operations. One of the operators, they were able to increase their yield by 3.7% and bringing the savings up to $20 million every year. GE Healthcare, they have leveraged the AR for doing the things. Now the things are being able to, the humans are able to finish their tasks 46% faster by the way of use of AR. And when you have 1 billion parts in an airplane, which part will go where? Using AR, it's very easy. Earlier it used to take a lot of time to do the maintenance, especially onto the wiring harnesses. They are now able to do it 25% quicker. And if you see, the savings are, I mean, the productivity improvements are of the tune of 30% or so, a little bit up and down. But that's the tune of productivity improvement you would see in the manufacturing processes by the way of Industry 4.0. So that's all I had about Industry 4.0. I open the floor for any questions if you have. Please go ahead. Sorry, I was continuously talking because it's a long PPT and I had to finish in 1 hour. Yeah, if you have any of the questions, you can unmute and ask the question. Or you can also type in the questions into the chat if you have any. Is Industry 5.0 full AI? No, it is not full AI, but AI is one of the element in Industry 5.0. And it is going to leverage AI and the variants of AI, for example, Gen AI and all those things. It is going to use all of those things. Even quantum computing will come into Industry 5.0. Okay.
I think
No
anyone have any questions, please feel free to chat in the type
You can
your
put it in the chat. You can just also, unmute and ask. Okay, where
yes.
is India in adopting 3D printing to building affordable houses? Well, India has started adopted. I mean, has already started 3D printing of houses. Especially the government has done this as part of the PM Awas Yojana. Not everywhere, but they have started. And India Post is now having one of the post offices which was 3D printed. So it is slowly coming in. Um, it may come from tier 2 cities to tier 1 cities. Tier 1 cities are already crowded. Having the 3D printing on site is slightly difficult until unless it's a new corridor which is being created. For example, UP is creating a lot of corridors. There, the 3D printing might be possible. Otherwise, the crowded tier 1 cities, it's slightly difficult. But research is going on how it can be made, accessible in the crowded areas as well. But yes, India is adopting the 3D printing for the affordable houses. Okay, what other questions do you have? Is 3D printing going to replace the traditional machineries completely? No, it will not. 3D printing is not very fast. That is one of the drawbacks. If you were to print, let's say, Eiffel Tower of this size, it can take up to 1 hour based upon what material you're using. Whereas if you were to create this using the traditional machineries, you can create hundreds of these things quickly. Especially in the complex design, 3D printing is better because they are able to print it faster as compared to the traditional printing. Just imagine if you have a product which has honeybee structure in between. In traditional manufacturing, you will have to create these parts separately and join it together. Whereas in 3D printing, it can be one full solid structure that can come up quickly. So 3D printing, it is not going to replace. It is certainly going to augment the traditional machineries. It is going to help, for example, in airplanes, in space technology, it is going to help all those things. It is not going to replace.
Okay, I think we have covered our questions, and I think, sir, we can conclude this session
Okay,
here.
great. Thank you. You have been a
Thank
wonderful audience. Have a
you.
good evening. Thank you. Bye
Thank
bye.
you so much, sir. Thank you, everyone. Have a great day. Take care.